Blood trickled down his forehead, pooling in the corner of his eye as he hunched over the drafting table in the dimly lit cell. The guards would return in 20 minutes. The calculations had to be perfect this time. His fingers trembled, not from fear, but from the toxins that had gradually accumulated in his system after 2 years of handling experimental propellant compounds without proper protection. Engineer Carl Weisman could barely hold the pencil steady as he made the final adjustments to the blueprint that would revolutionize German artillery and potentially turn the tide of the war. The same blueprint that would eventually destroy what remained of his life. Outside, the distant thunder of Soviet artillery pounded relentlessly against German positions along the Eastern Front. Each concussion reminded him of his desperate bargain: freedom through genius, survival through betrayal of his principles. The bitter December cold seeped through the concrete walls of the special prisoner section in the Krupp weapons facility near Essen, but Carl barely noticed anymore. His body had gone numb months ago from the endless cycle of 18-hour workdays followed by fitful sleep on a wooden plank. How did you end up here, designing weapons for the people who imprisoned you? The question haunted him constantly. 3 years earlier, he had been a respected artillery systems engineer with no political affiliations, simply trying to survive in a nation consumed by war. Now he was prisoner engineer 27891, the man whose revolutionary firing mechanism would save thousands of Wehrmacht soldiers, while costing him everything he had ever valued: his freedom, his health, his soul. The guards called it the Miracle Blueprint, an elegant solution to the chronic jamming problem that had plagued the German 88mm artillery system since the invasion of Russia. The Soviets had learned to exploit this flaw, timing their armored advances to the precise moment when German gun crews were frantically clearing jammed breach mechanisms. What the guards didn't know was that Karl had deliberately delayed creating this solution for nearly a year, hoping to sabotage the Nazi war machine from within. That strategy ended when Oberst Wagner executed 3 fellow prisoner engineers as an example. The message was brutally clear: deliver results or die. Karl's hands continued trembling as he folded the blueprint that would forever link his name with both salvation and damnation. In 3 days, his design would save 78 German gun crews at the Battle of Kursk. Within 3 months, it would increase German artillery effectiveness by 67% across all fronts. And within a year, the same brilliant mechanism would mark him as a collaborator, ensuring his post-war imprisonment by the Allies, if the deteriorating nervous system damage from the propellant chemicals didn't kill him first. The door swung open behind him, flooding the small room with harsh light from the corridor. "Time, prisoner engineer. Oberst Wagner wants your final report now." Karl gathered the blueprints with shaking hands. The designs would leave with him today, but he would never truly leave them behind. Carl Weisman had not always been a prisoner. In the early 1930s, he had been one of Germany's most promising mechanical engineers, specializing in hydraulic systems at the renowned Technical University of Dresden. When most of his colleagues eagerly joined various Nazi technical organizations, Karl remained stubbornly independent, focusing solely on his research into pressure management systems for industrial applications. His papers on fluid dynamics had earned him modest recognition in engineering circles, but his refusal to join the party made him increasingly isolated as Hitler's regime tightened its grip on academic institutions. The coming of war changed everything. Germany's rapid military expansion created an insatiable demand for engineering talent, and Karl's expertise in hydraulic systems made him a prime target for recruitment by the Wehrmacht's weapons development programs. He initially avoided conscription by accepting a position with a civilian contractor that supplied components to the Krupp weapons factories, hoping to remain at a safe distance from direct military work. For nearly 2 years, this careful balancing act succeeded. Then came the catastrophic failures of German artillery during Operation Barbarossa. The Russian winter of 1941 had exposed critical weaknesses in the vaunted German 88mm guns. Hydraulic fluid systems froze, breech mechanisms jammed, and recoil compensators failed catastrophically, often killing gun crews. As German casualties mounted, the Reich's desperate search for solutions led them directly to specialists like Karl Weissmann. One cold morning in January 1942, the Gestapo arrived at his modest apartment in Dresden. The charge was sabotage through inaction, a newly created offense that criminalized the failure to volunteer one's expertise for the war effort. His trial lasted exactly 7 minutes. The verdict? Guilty. The sentence, indefinite confinement to a special prisoner engineering section at the Krupp Works in Essen, where he would apply his expertise to solve the artillery failures or face execution. The first 6 months of Karl's imprisonment were a nightmare of adjustment. Housed in a converted storage building adjacent to the main factory, the prisoner engineering section contained 34 engineers and scientists whose political reliability was considered questionable, but whose technical skills were too valuable to waste. They worked under the direct supervision of Oberst Heinrich Wagner, a fanatical artillery officer whose career had been nearly destroyed by equipment failures on the Eastern Front. Wagner understood just enough about engineering to recognize competence, but not enough to detect subtle forms of resistance. Karl and his fellow prisoner engineers initially engaged in a dangerous game of appearing productive while deliberately introducing minor flaws into their designs that would cause failures in the field. This silent sabotage continued until August 1942, when Wagner received reports about systematic failures in recently modified artillery units. Wagner's response was immediate and brutal. He selected 3 engineers at random and executed them in front of the others. "Your hands build our victory, or your blood fertilizes German soil," he announced to the survivors. "The next failure will cost 6 lives. The one after that, 12. Choose wisely." For Karl, that moment marked a terrible crossroads. Continue his sabotage and cause the deaths of colleagues, or apply his genius to perfect weapons that would kill Allied soldiers and extend the Nazi regime. He chose a third path, working on components that would protect German gun crews from mechanical failures, while subtly designing systems that would deteriorate rapidly under field conditions, requiring frequent replacement and disrupting supply chains. The bitter irony was that even this compromise solution made him extraordinarily valuable to the German war effort. Artillery crews were expensive to train and difficult to replace. Karl's modifications saved thousands of them from death by equipment malfunction. By mid-1943, his redesigned hydraulic recoil systems and cold-weather breech mechanisms had increased the operational reliability of German 88mm guns by over 60%, allowing sustained fire in conditions that would have rendered previous models useless. Karl's most significant contribution came in response to a specific battlefield problem reported from the Eastern Front. Soviet forces had developed tactics that exploited the 30-second vulnerability window when German guns experienced feeding jams during rapid fire sequences. Red Army tank commanders would time their advances to coincide precisely with these predictable failures, often overwhelming gun positions before the crews could clear the jams. Oberst Wagner presented this challenge to the prisoner engineering section with a simple ultimatum: solve it within 30 days or half the section would be executed. Karl recognized that the fundamental issue lay not in the breech mechanism itself, but in the feeding system that delivered shells to the breech. The extreme temperature variations on the Eastern Front caused minute expansions and contractions in metal components, creating friction points that led to catastrophic jams. His solution was revolutionary in its elegant simplicity: a self-adjusting feed mechanism, incorporating temperature-responsive alloy elements that automatically compensated for thermal expansion. The design required minimal retooling of existing manufacturing processes and could be retrofitted to guns already in the field by moderately skilled technicians. When tested under simulated extreme conditions, the modification reduced jamming incidents by 94%. The first field deployment of Karl's design came at the Battle of Kursk in July 1943. 78 artillery pieces equipped with his modified feed mechanism maintained continuous fire throughout the engagement, proving devastatingly effective against Soviet armor. Wehrmacht after-action reports specifically credited the modification with preserving several critically exposed flanks during Soviet counterattacks, saving an estimated 2,000 German lives. For Karl, the success brought no joy, only a sickening awareness of his complicity in extending a war that was consuming millions. Yet his position within the prisoner engineering section improved marginally. He received slightly better rations, a small private cell instead of the shared dormitory, and, most significantly, access to technical journals and research materials previously denied to prisoner engineers. He used these privileges to expand his knowledge of artillery systems, searching constantly for a way to escape the moral trap he inhabited. The opportunity came in late 1943 when he was assigned to solve another critical problem: the increasing shortage of strategic materials needed for artillery production. The German war machine was starving for copper, tungsten, and high-grade steel, all essential components in traditional artillery design. Karl proposed a radical redesign of the 88mm gun that would reduce strategic material requirements by 47% while maintaining combat effectiveness. The concept centered on a composite barrel construction technique using layered steel of varying grades bonded under extreme pressure, combined with a revolutionary breech mechanism that required minimal rare metals. On paper, the design was brilliant, a potential game-changer that could allow Germany to dramatically increase artillery production despite resource constraints. What Oberst Wagner and the Krupp manufacturing directors didn't know was that Karl had deliberately incorporated a fatal flaw into the design. The composite barrel structure, while theoretically sound, would develop microscopic stress fractures after approximately 200 firing cycles. Not enough to cause catastrophic failure that might kill German crews, but sufficient to render the guns increasingly inaccurate and eventually unusable. By the time this flaw became apparent, thousands of the new guns would be deployed, consuming precious resources that could have been used for more conventional, reliable designs. The trap was set, but Karl never saw it sprung. In February 1944, as the first prototypes of his composite design were entering testing, Allied bombers targeted the Krupp facilities in Essen. The prisoner engineering section took a direct hit during a daylight raid, killing 17 engineers and severely damaging the complex. In the chaos that followed, security procedures broke down, and Karl saw a desperate chance for escape. Using his knowledge of the facility's layout, he navigated through damaged sections, evading the few remaining guards. For the first time in over 2 years, he stepped beyond the perimeter fence. Freedom lasted exactly 7 hours before he was captured at a checkpoint 10 miles from the facility. The Gestapo interrogator who processed his recapture seemed almost impressed by the attempt, noting in his report, "Subject displays remarkable resourcefulness. Recommend highest security protocols and continuation of special project access under enhanced supervision." Karl's punishment was not execution, as he had expected, but something possibly worse. He was transferred to a smaller, more secure facility near Paderborn that specialized in experimental propellant formulations, an area completely outside his expertise. Here, under the direction of SS Sturmbannführer Erwin Dietrich, he was forced to test highly unstable compounds without proper protective equipment. The work was a death sentence delivered in slow motion. Within weeks, he began experiencing the first symptoms of chemical poisoning: tremors in his hands, blurred vision, intermittent paralysis in his extremities. The facility medical officer documented these symptoms clinically, but offered no treatment. His notes, discovered after the war, stated simply, "Subject showing expected deterioration from compound exposure. Estimate remaining useful work capability, 3 to 5 months." Despite his deteriorating health, Karl's engineering mind remained sharp. When shown artillery performance reports from units using his earlier modifications, he identified further potential improvements. Sturmbannführer Dietrich recognized an opportunity and offered a devil's bargain: design one final, comprehensive upgrade to the 88mm system and receive medical treatment for his condition. The alternative remained unstated but obvious: continued exposure until work became impossible, followed by disposal. In this darkest moment, trapped between slow death and complicity and more killing, Carl made his final, desperate choice. He would create the blueprint requested, the most refined, effective artillery system possible, but with a crucial hidden element. Within the elegant redesign of the entire firing mechanism would be a conceptual seed, a fundamental engineering approach that would be studied and adapted by the Allies after the war, leading to significant advancements in safety systems that would ultimately save more lives than his weapons had taken. Working through increasing pain and neurological deterioration, Carl completed the comprehensive blueprint in April 1944. The design incorporated all his previous innovations while adding a revolutionary synchronized firing sequence that increased rate of fire by 38% without sacrificing accuracy or reliability. German artillery officers who reviewed the design were ecstatic, immediately ordering full production implementation. True to his word, Sturmbannführer Dietrich arranged for Karl to receive treatment at a specialized medical facility in Berlin. The doctors there confirmed what Karl already knew. The neurological damage was irreversible. The tremors would worsen, eventually leading to complete loss of motor control. The best they could offer was palliative care to manage pain and slightly slow the progression. Rather than return Karl to the propellant facility, Dietrich reassigned him to a theoretical research role at a secure documentation center in Berlin. Here, with the assistance of scribes who could compensate for his deteriorating handwriting, Karl continued refining artillery concepts through the final year of the war. His designs were implemented across German artillery units on both eastern and western fronts, credited with maintaining effective defensive capabilities despite increasingly desperate strategic circumstances. As Allied forces closed in on Berlin in April 1945, Sturmbannführer Dietrich made one final appearance at the documentation center. He presented Karl with a choice: evacuation to a rumored Alpine redoubt where critical Reich scientists and engineers were being gathered, or remaining in Berlin to face whatever came with the Soviet advance. Karl chose to stay, his body now so compromised by chemical damage that movement caused excruciating pain. When American forces secured the documentation center in early May, they discovered Karl among thousands of technical documents. Initially detained as a Nazi weapons developer, his status quickly became complicated as investigators pieced together his history as a prisoner engineer. Medical officers documented his severe neurological damage and recommended transfer to a specialized facility in the American occupation zone. For nearly 8 months, Karl existed in legal limbo, neither formally charged as a war criminal nor officially recognized as a victim. His technical expertise made him valuable to Allied intelligence officers seeking to understand German weapons development, but his role in creating systems that had killed Allied soldiers raised difficult questions about culpability under duress. The resolution came through an unexpected channel. A young British artillery officer reviewing captured technical documents recognized the brilliance in Karl's designs, particularly the safety innovations incorporated into the synchronized firing system. Captain James Harrington had lost men to artillery malfunctions and immediately grasped the life-saving potential of Karl's engineering approach if adapted for peaceful purposes. He began advocating for Karl's formal recognition as a forced contributor rather than a willing participant in the Nazi weapons program. In January 1946, a special Allied technical commission reviewed Karl's case, including testimony from surviving members of the prisoner engineering section who confirmed the coercive conditions under which they had worked. The Commission's finding acknowledged Karl's technical contributions to the German war effort while recognizing the extreme duress under which those contributions were made. He would not face war crimes charges, but would remain under Allied supervision due to his technical knowledge. This qualified freedom came too late to offer much comfort. By mid-1946, Karl's condition had deteriorated to the point where he required constant medical care. The tremors now affected his entire body, and he could communicate only through a specialized writing board designed by sympathetic American engineers. Yet his mind remained tragically sharp, aware of every limitation imposed by his failing body. In this condition, Karl made a final significant contribution. Working with Captain Harrington and a team of Allied engineers, he helped adapt his synchronized firing system concepts into safety mechanisms for industrial equipment. The fundamental principles he had developed under threat of execution were transformed into innovations that would eventually protect thousands of workers in manufacturing facilities across Europe during post-war reconstruction. Karl Weissmann died on October 3, 1947, from complications related to his chemical exposure. The official medical record listed the cause as progressive neurological deterioration resulting from industrial toxin exposure, making no mention of the circumstances under which that exposure occurred. He was buried in an unmarked grave in the civilian section of a former military cemetery near Frankfurt. For nearly a decade, his story remained buried in classified Allied technical intelligence files. His name appeared only in dry technical appendices to artillery development histories, noted as the designer of several key modifications to German systems. No mention was made of his prisoner status or the coercion under which he worked. This historical erasure might have been permanent if not for the efforts of Captain Harrington, who had returned to academic engineering after the war. While researching a paper on the evolution of artillery safety systems in 1957, Harrington became increasingly troubled by the absence of Karl's personal history from technical records. With Cold War tensions at their height, he faced significant resistance when attempting to access classified files related to German weapons development. Persistence eventually yielded results. In 1959, Harrington published Engineering Under Duress, the Karl Weissmann case, a carefully documented account of Karl's imprisonment and forced contributions to German artillery development. The paper challenged comfortable narratives about clear moral boundaries during wartime, highlighting the impossible choices faced by those caught between collaboration and death. Initially met with controversy and attempts at suppression, Harrington's paper eventually sparked a re-examination of the roles played by coerced technical specialists during the war. Military historians began distinguishing between willing participants in Nazi weapons programs and those who contributed under explicit threat. Engineering ethics courses at major universities incorporated Karl's story as a case study in the moral dimensions of technical work. In 1963, 16 years after his death, Karl Weissmann received a form of posthumous recognition when the International Engineering Safety Association established an award in his name, honoring innovations that transformed military technology into civilian safety applications. The first recipient was a team that had adapted his synchronized timing principles to create emergency shutdown systems for nuclear power facilities. Perhaps the most fitting acknowledgement came in 1972, when the German Federal Archives formally reclassified Karl from technical contributor to Wehrmacht weapons development to prisoner engineer under duress. This bureaucratic adjustment could offer no comfort to the man who had died decades earlier, but it established an important historical distinction for the record. Today, military museums in 3 countries display 88mm artillery pieces incorporating Karl's modifications, usually with technical descriptions of their mechanical innovations. Only one, a small private museum in Dresden, includes a photograph of Karl Weissmann and a brief account of the circumstances under which he developed his revolutionary designs. Beside the display stands a simple placard with words attributed to him from a final letter to Captain Harrington. Engineering should preserve life, not destroy it. Remember that every technical solution serves human ends. Choose those ends carefully. The full measure of lives affected by Karl's work remains impossible to calculate with precision. Wehrmacht records suggest his artillery modifications directly preserved an estimated 11,000 German lives through prevention of catastrophic mechanical failures. Allied casualty reports indicate that increased German artillery effectiveness resulting from his designs contributed to approximately 17,000 additional Allied casualties during the war's final 2 years. After the war, safety applications derived from his firing synchronization concepts prevented an estimated 23,000 industrial accidents over 3 decades across Europe and North America. The engineering principles he developed under imprisonment eventually found their way into applications ranging from medical equipment to transportation safety systems, creating a complex legacy that defies simple moral categorization. Carl Weissman's life encompasses the central paradox faced by technical specialists in wartime. Knowledge that can preserve life can equally destroy it. Expertise that can liberate can also enslave. His blueprint revolutionized German artillery, saving thousands of Wehrmacht soldiers while extending a brutal war and leading to his own physical destruction. His genius served masters he despised and ideals he rejected. In the end, he found a measure of redemption by ensuring his knowledge would ultimately serve life rather than death, embedding principles in his designs that would find their greatest expression in peacetime applications he would never live to see. The trembling hands that drafted weapons of war under threat of execution also planted seeds of safety innovations that would blossom long after those hands had stilled. In that duality lies both the tragedy of his life and its ultimate meaning, a reminder that even in the darkest circumstances, human ingenuity can contain within it the possibility of future light. As artillery museums gradually transition their 88mm displays from glorification of technical achievement to more nuanced historical context, Carl's story offers an essential perspective on the human dimension of wartime technology. Behind every weapon system stands not abstract national will, but individual human beings making choices under constraints we can scarcely imagine from the comfort of peace. For those who build the technologies in Carl Weissman's life, perhaps it is this: technical brilliance without moral compass becomes merely efficient destruction. Knowledge without humanity becomes merely sophisticated barbarism. His blueprint revolutionized artillery, but his true legacy lies in the question his life continues to ask of every person who applies specialized knowledge in service to power. What will you do with your expertise when the cost of refusal becomes unbearable? For those who build the technologies that shape our world, there may be no more important question.